And we're live, and we are live. Welcome to another episode of Bitcoin Developers. Got another great episode in store for you today. As usual, thanks for everyone who's tuned in already. Love to hear where you guys are kind of tuning in from. Let us know where you are. Let us know where you're hanging out. I've got my friend with me today, Alekos. He's gonna give us another good workshop around the Bitcoin Dev Kit again today. Nashville stand up. Shout out to Nashville. Heard it's a lovely, lovely place. I'm gonna put it on my to-do list of places to go. Actually, heard very good things about Nashville. So we can kind of dive straight in again today. So we'll start with like a introduction for Alekos, and then we'll talk a little bit about what we're going to be working on today. So Alekos, welcome to the show.
Thank you. Thank you for having me here.
No problem. Pleasure. So yeah, I guess for what we've been doing with all of the guests so far is just giving the viewers and the listeners a little bit of background about yourself. So how did you get into Bitcoin development?
This is actually a bit of a complicated answer for me because I kind of started randomly. There wasn't like a point where I said I want to become like a Bitcoin developer. It all happened kind of slowly over time. But I've been working in Bitcoin for, I think, 4 years now. I started at the end of high school, just reading about it and then doing like little projects by myself. And then I had the chance I met Giacomo Zucco, which is pretty famous on Twitter, in Milan. He basically interviewed me for a job, and I ended up working with him for a little while. So that was like the first proper Bitcoin job I had, and I was working mostly on Lightning stuff there. This was 2017, so Lightning was pretty new. We were doing like not really on the core Lightning, just doing like applications or web dashboards for Lightning, things like that.
Mm-hmm.
Then after a while, I joined Blockstream. I worked on the green team on the Bitcoin and Liquid wallet for green. And while I was there, I started BDK as a kind of a hobby project. And then I managed to get funding from Tether initially, Bitfinex and Tether, and now from Brink. So I managed to find funding to work on this project full time. So yeah, this is kind of the whole story in these 4 years that feel much more than 4. Everything, a lot happened during this time.
Yeah, I can imagine it feels longer than 4 years. So just going back to a few things. So you mentioned you started the BDK. What inspired you to start it, and like what's the BDK all about? We have had quite a few sessions on BDK already from some of the other contributors. But from your perspective, like why did you start BDK, and what's the BDK all about?
So basically, as I mentioned, I started BDK when I was at Blockstream. So I was working on Bitcoin wallets, like full-time professionally already, and specifically Blockstream Green. And the kind of, I don't know, the inspiration, I would say, came from thinking about how many cool things you could do on Bitcoin by using the scripting language to like the maximum power, let's say. I was basically noticing that the Bitcoin scripting could do a lot of stuff, but there were no products actually using those. And Green, the Green wallet itself, kind of uses some advanced features, but I think we could do a lot better. So this was kind of the inspiration to start the project that would make it very easy for developers to fully use Bitcoin, like do everything you can actually do at the protocol level. So yeah, this is where it kind of started.
Okay, awesome. And how have you found like the progression of like the BDK since you started it? Is it like kind of where you expected it to be at kind of this many years into it, or is it kind of surpassed your expectations so far?
Yeah, I think it did surpass my expectation. I wasn't expecting that. So like when I started, I was just by myself doing it in my free time. And then I managed to find funding, and I was just by myself doing it full time. And I thought that was like, this is it. I'm just going to maintain this project by myself. Maybe I'm going to get some contribution every once in a while. But now there are like, I think 4 developers working almost full time on it, and then a few other people just contributing a lot. So yeah, it's much bigger than I was, I think, expecting when I started, than I would have expected.
Yeah, I can imagine, and the Discord community is quite lively over at BDK as well, and definitely going to start seeing more projects integrate with it over this next year for sure. The other thing you mentioned was funding, and I think one of the organizations you mentioned was Brink. How did that opportunity come about for funding to work on this stuff full time?
I basically just sent an application when they opened basically the first round of grants. I think they were just starting out. So I was one of the first Brink grantees. So yeah, I just sent an application. I said, look, I made this project. At the time I was being funded by BFinex, but I was not working completely full time on this. I was doing this and other open source projects, and I wanted to work full time just on BDK. So I sent the application, and they accepted me. So yeah.
Okay, that's very cool. And yeah, because I get a lot of questions, especially recently since doing these streams and being on different types of panels and stuff about like how people can get into Bitcoin development full time and like make a career out of it. So like, do you have any advice for people who, one, want to get into Bitcoin development, and 2, is it a viable career choice?
So, well, I'm going to answer the career question first. I think it is. So I think personally, I feel like there could be, like, if you're just looking for money, maybe Bitcoin, the Bitcoin career is not the best for you, because I think like if you end up working in startups, it's very hard for startups to find like a nice business model, because everything is open source, everything is free. So in general, I would say it's not like the best paying career ever, but I think it's very satisfying to be working on this new technology. So I think it is, and it's still like you can make a very good amount of money. It's not that you are gonna starve.
Yeah.
And I don't know, in terms of tips, I guess just for me, it really helps to, I like to make like prototypes and build stuff. So this is actually the way I started. I was still in high school. I started building little things, and then I showed these things to, in this case, it was Giacomo, but there are many other companies out there that do Bitcoin stuff, consultancy. And if you just show them something you've built and they like it, usually this is a great way to get known. So in general, I would say just if you're passionate about this, keep studying, keep building stuff, and eventually some company's probably gonna hire you.
Okay, awesome. So yeah, gotta show that proof of work, I guess, and that dive straight in. Don't be scared to like volunteer on some of these open source projects, whether it be BDK or LDK or any other project. The communities around them are super welcoming and like very much ready to guide you along your journey to contributing and learning more about the space. So definitely like dive in head first and don't be afraid. Cool. So if people want to like follow you and that kind of stuff, is like your Twitter probably a good place to start, and then kind of go from there?
Yeah, that's I don't tweet a lot,
Okay.
but yeah, I follow the Bitcoin Twitter community. So yeah, if you want to follow me,
Okay.
yeah, you can find me there.
Okay, cool. All right. I've got a few other quick things to mention around conferences. So if there's anyone interested in Lightning, there's a conference in Istanbul at the end of this month from February 25th to the 27th. I think it's Fulmo are hosting this one. So they're doing a Lightning Network Hack Day. So if anyone's interested in coming along to that, like get your tickets and come and join us. I'll be there. a few members from the Bitcoin design community there, and from the wider community as well. So that should be a fun few days. We also have Advancing Bitcoin coming up in London on the 3rd and 4th of March. So be sure to grab your tickets for that as well. That's an amazing conference. We didn't unfortunately have it last year, or maybe even the year before. Time's gone so quick. But this conference is filled with awesome talks and workshops and really good networking opportunities, and some amazing speakers are going to be there as well. So definitely encourage you to attend that one if you can. And then obviously we've got the huge one in Miami on when is the Miami? It's the 6th to the 8th, right? So and they have an open source stage now, which is going to hold a capacity of 1,000, which is going to be really good. So there's going to be a lot of good fireside chats and talks and workshops going on at Bitcoin 2022 as well. So be sure to make a best effort to get over to those as well. And then lastly, just gonna chill this a little bit. So I've spent a little bit of time trying to collate some of the streams that we're doing here over at Bitcoin Developers .xyz. So here you can find the list of all the previous streams, learn a bit about what the show's about, and over time we'll be developing like a schedule for you to add to your calendar, so you know all of the up and coming episodes. And be sure to follow us on Twitch and watch back on YouTube if you're unable to watch us live. So having said all of that, we're gonna start our workshop today, and our workshop's going to be based around something called Taproot, which is one of the most recent upgrades to the Bitcoin protocol, a different way of sending transactions, something that is likely to improve privacy and have some other benefits. So before we dive into the practical side of things, we're going to talk a little bit about what Taproot is and why it's important. So let me hand off to you a little bit here, Alekos. What is Taproot, and what does it kind of mean for Bitcoin?
Yeah, so basically the Taproot upgrade is actually two big upgrades that they came together, that were activated at the same time, and one kind of builds on top of the other. So the first one is Schnorr signatures, which is a different signature scheme. Let's say the legacy scheme that we've been using on Bitcoin since the beginning is a CDSA, which is very standard, very popular, and it was very popular at the time when Bitcoin was launched. Schnorr is very similar in terms of math, but it has some advantages, mainly around the way that signatures can be aggregated. So the fact that you can create one public key that is actually made by many public keys being aggregated, which is shown here. So instead of building the classic multi-sig setup where you have a list of public keys in the script, you can have one single key in the script that is an aggregation of many other keys. And this has privacy advantages because from an outside observer, you only see one key. You don't know if this key is a single person or a single entity or many. And also it has scalability advantages because you're just saving one key, one public key in the transaction. You're just adding one key to the transaction, so it's much smaller. You pay less fees, and it bloats the blockchain less. So this is the first kind of upgrade, Schnorr signatures. And the second upgrade is I think this is what is actually called Taproot, but anyway, it's basically the concept of having a tree of scripts and only revealing the one you actually end up using. So basically the concept is before Taproot, you could have very complex scripts, like scripts where you have many different possible outcomes or many possible spending conditions, where I could say, I can spend always, or you can spend after a year, or I don't know, those two other people can spend together after 2 years, and you could do many conditions or together. So you could use whichever you wanted. But the problem with this was that the script would become very large. So your transaction would become larger because you have to put the entire script in the transaction. And also in terms of privacy, you would be like fingerprinting yourself a lot. Like if you use a very special particular script, you could see those transactions in the blockchain that all use this same like structure, and they could be linked together to the same wallet. So the idea of Taproot is we can take many, basically split up those conditions. So like it could be, I can spend always, you can spend after a year and everything. And we can aggregate them together to form a tree. And then when we actually use one of these scripts to spend, we just reveal the one we've used. So we can hide all of the others and only reveal the one we want to use. And actually, there's also another optimization on top of this, which is the fact that when you bring together Schnorr signatures and Taproot, basically you can hide this tree in a single public key. So your typical Taproot address is just one public key, and you can either sign with the corresponding private key, and this would correspond to basically a single signature, or a multi-signature, n of n multi-signature if you have many keys aggregated, or you can reveal that there was a tree in there, and then reveal which one of the leaves of the tree you used and satisfy that leaf. So basically the point is you get a lot of privacy because you can hide a lot of information. You get a lot of scalability because those information are not in the transaction, so they don't end up taking space. And it's overall a very big upgrade for Bitcoin that lets you basically build more complex interactions on Bitcoin without sacrificing costs and privacy.
Okay, that was an awesome explanation. And so there's a lot there, and hopefully some of it will make more sense if anyone listening or viewing is a little bit confused by that. Hopefully it will make more sense once we start practically coding some of the stuff. But as it being such like a significant and arguably big change to the protocol, like what did it, I wanted to touch a little bit on like what did it look like to get this into Bitcoin? Because like did everyone just like agree that this was cool and Bitcoin needed this and like we're good to go? Or what does that process look like for when such significant things need to be added?
Yeah, that was it wasn't like the smoothest, I would say. Or actually, it ended up being very smooth, but people were prepared to having to fight basically, like they did with Segwit. So there was a lot of, well, naturally, when you want to make a big change to Bitcoin, there's a lot of discussion going on before in terms of spec, and then proposing, making BIPs, proposing changes, writing code and everything. When you get to the point where okay, this is good, we want to activate this, then you have to figure out how you want to activate. So there are a few ways. I don't actually remember the BIP number, but there are basically a couple of ways, which could be, we can let miners signal if they are ready to support this change. And if we manage to reach like a threshold, then it activates. There's also another way, which is a bit more of an aggressive way, where you could say, we give miners time to signal, and if they don't signal in 2 years, it's going to activate anyway. So like they can activate it earlier if they signal, or so many people were prepared to use this super aggressive way because they were scared miners would basically not signal for Taproot like they did for Segwit in 2017. But in the end, it all went fine. So in the end, miners signaled, the threshold was reached, and it just activated fine. So there was a lot of drama before to choose which way to use, but in the end, it actually went very smooth.
Okay, cool. And got a question. I'd be curious to learn more about Taproot, and was looking for something similar to Mastering Bitcoin, the book, but focusing on Taproot. What's a good resource to read about Taproot? Any advice there?
I think if you want something very technical, this PDF you are showing, so the Taproot workshop that was done by the Bitcoin Optech guys, I think this is very, very technical, kind of like mastering Bitcoin. So that's probably a good start.
Okay, that sounds good. And this was September 2019. Okay, cool. And then just from a user point of view, then does much change? We have this new address type, but what changes much for the user? Is there a lot that changes, or?
Well, I would say for the typical user that just uses a single sig wallet, with a single sig wallet, it doesn't really change that much. If they move to Taproot, they would make slightly smaller transactions, so they would be slightly cheaper, but nothing like major. The main advantage is for people who use more complex scripts, like even just a multi-sig, you can benefit a lot because you can aggregate keys, and you save a lot of money, and privacy is much better. And if you have even more complex scripts, like if you take Lightning, for example, Lightning would probably benefit a lot because in Lightning you have a lot of edge cases, worst case scenario. Like I have this script branch which I'm going to use if the other party tries to steal my money, but most of the time you just don't use it. But it needs to be there. So with Taproot you could basically hide that, and you only use it when you actually have to. So for users, typical user, it doesn't really change a lot, but for more complex protocol, it can really improve a lot.
Okay, amazing. Okay, so we're gonna try our hand at doing some Taproot transactions today. And do you want to maybe give us a quick overview of what we're setting out to achieve by previewing some of the Taproot transaction capabilities via the BDK?
Yeah, so basically, well, maybe I can do a very quick introduction of BDK, even though you've probably done it already in the previous
Yeah,
stream.
of course, yeah.
Basically, BDK is a library. It's a Rust library that you can use to build Bitcoin wallets, very generic Bitcoin wallets. You could do, in theory, everything that can be done, that the Bitcoin protocol allows you to do. And you do that through descriptors. So you have those text strings which you can use to represent what you want your wallet to do. Basically, you could say, I want just a single sig wallet, or I want that both these keys need to sign. So you can do multi-sig wallets. You can do time-locked wallets where you can't spend before some amount of time. So basically, this is BDK today, with the BDK that we have released. It supports all of these opcodes that you're showing here. The version of BDK that we're going to be using today for the Taproot thing is actually a fork. So it's not the official release BDK. It's a fork I made where I basically I was just prototyping Taproot changes. So it's not super well polished. There are bugs here and there. But this is why we called it a preview, because it's probably what it's gonna look like in the end.
But it is cutting edge. It is super cutting edge.
Yeah, exactly.
Okay, that sounds cool. Right. Any questions from the listeners, from the viewers, before we dive in? I think we had a question earlier. Do all these links in the chat stay attached to the video when releasing it? Yeah. So we'll make sure we'll provide all the links in the show notes after. But yeah, I guess without further ado, we've got just over an hour to jump in. So we're going to try and create a Taproot transaction and broadcast it over testnet, and hopefully you guys will be able to see it in some type of block explorer. So, all right, cool. So, Alekos, do you feel ready to start? Ready to get going?
Yeah, let's start.
Okay, cool. Let me change to pair programming view. Give us a second here. So let me move a few things around. And okay, I will share my screen again. Entire screen. Okay, Okay, I think we're all good. All right, so yeah, I did take the onus to create a sample project earlier. So let me see if I can find that. Let's go here into projects. And what did I call it? I've forgotten what I've called it. I called it Taproot BDK. And just open it in VS Code, see what we've got to start. And okay. So yeah, so we've just got like a standard, just like cargo new project that creates a main function for us, some Git stuff. It's been built already, and then like just a cargo.toml file to include our dependencies. So maybe we start here then. Maybe we start with the dependencies and like what we need, because you mentioned earlier that it's not actually part of the official BDK releases, and I've kind of included the latest version of BDK here with some features. So like what needs to change here for us to get access to the cutting edge fork that you have created?
Yeah, exactly. So you can basically remove everything in the curly brackets because this is what you use, especially the version tag is what you use when you take a release version from the Rust repository. But here you're going to take it from my GitHub directly. So you're going to write like git equal. And then in quotes, I don't know, maybe you might want to copy paste or
yeah,
I can
that.
spell it for you.
Yeah, no, let's copy it because I'm bad at spelling as well. So this is just pointing at your GitHub repository, yeah?
Yeah, my fork of BDK, and then you also need to specify which branch. So you can use comma branch equal, and I think it was called Taproot dash testing.
Taproot dash testing.
Cool. And this should be it for BDK, but we actually need to do another thing, which is again connected to the fact that we are using a custom branch, basically. The problem is actually, if you want to try to compile, it's going to fail. And maybe we can talk about why it's failing.
Yeah, that sounds good. So if we do cargo build. Okay, so blocking, waiting for file lock on build directory. It's trying to build some things.
Yeah, it should fail with some errors from Electron, basically. And the problem here is that behind the scenes, so this fork of BDK is also using a fork of Rust Bitcoin. So it's not using an official Rust Bitcoin version because I had to change some stuff there. And you can see it there that Bitcoin was downloaded from GitHub as well. And Miniscript as well.
This line here.
But Miniscript in this case is fine. Exactly.
Yeah.
So this is Rust Bitcoin. Instead of using the official version, is using this fork. But the problem is that BDK also depends on Electrum, on a library that deals with Electrum servers. And the Electrum library uses the official version of BDK. So like you have two libraries using two different versions of of Bitcoin. One is using the official version of Bitcoin, one is using the custom version. And for Rust, they are basically different types, so they can't be interchanged. So the error here is, I was expecting this, but you're giving me that.
Okay, so expected struct.
In this case, we need to use
blah 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 found struct Bitcoin. Got you. Okay. Yeah.
It's called the same. So it's a Bitcoin transaction, but one is from the official version and one from the custom version, so they can't. So basically, we need to. It's called patch. We need to patch the dependency. So we need to basically tell. We're basically overriding dependencies of our dependencies. So we are saying, I know that BDK depends on Electron client. We want to change which version of Electron client BDK depends on. So it's not our dependencies, it's the dependencies of our dependencies, like one step down. I don't know, maybe it's better if you copy paste this again, because there are.
So let's see here.
There's a lot of spelling. I can explain what it's doing.
Yeah, let's
afterwards.
do that. I got a question though. So Electrum client, like I kind of do know what it means, but I'm just playing what it is. I'm just playing devil's advocate a bit here. Like Electrum, like what is Electrum? Is Electrum a Bitcoin node, or like how does that work? Is that one of our ways of interacting with the blockchain? Like how does that work? Does that need to be running locally? Can that be running like on a server online somewhere? How does a little bit about that work?
Yeah. So basically, Electrum is a Bitcoin wallet. A Bitcoin wallet is very popular. One thing about Electrum, the wallet, is the fact that you can use it without having a full node. So your wallet needs to fetch blockchain data and also send back like transactions in some way. So the Electrum protocol was developed, which is basically like a protocol that describes a client server model where this is the wallet. And this wallet uses the Electrum protocol. It was developed for this wallet. So you have this client server model where the server has a full node and also an extra basically index on top of it. And you as a client, you connect to the server, you can ask, you can send queries or send back data. So like you could say, tell me all the transactions that involve this address or broadcast this transaction for me. So this is like a proxy that sits between your wallet and a Bitcoin node. And there are public servers running, so you can just use those servers. You don't have to host one yourself. Although you can do it if you want, but it's not a requirement.
So today, are we just going to use one of the trusted servers? Yeah.
Yeah, we're basically going to use the Blockstream public server that they also use in their product.
Okay, cool.
I mean, the worst thing is the privacy leak that they do. It's not that the server could steal your money. It's just the server knows a lot, get to knows a lot about you. But in this case, it's fine.
Yeah. Okay. That's
and here this patch thing is just we are patching the dependency of BDK. We are telling use this custom fork of Electrum client that is using the right Bitcoin version.
Okay, cool. That makes sense to me. All right, cool. Is that everything in terms of dependencies and overriding dependencies, or is there a little bit more here?
Yeah, this should be, because BDK exports everything we need. So we just need to include BDK, and then we can take Rust Bitcoin from BDK that exports it to us.
Okay, awesome. All right, cool. So where should we head over to next? Should we head over to like our main file and start having a play there?
Yeah. We can start writing with Rust code.
Okay.
Okay, so I was thinking maybe the first thing we need to do is generate some keys, because we're gonna use them afterwards. One of the limitations, I would say, of this Taproot fork is that it doesn't support extended keys. Basically, it doesn't support keys. These are like xpub or xpriv, the keys that you can derive. So we usually call those extended keys because you can generate many other keys from those. But it doesn't support those. So you can only use single, like old style private keys, the WIF format, like the string format where you have one key for one address and that's it. So we're gonna have to generate a few of those. I'm generating a few. We're gonna need one for the first example, which is like the single sig simple Taproot wallet. And then if we have more time and we want to do something more complicated, we're gonna need more. So I would just generate more now. So this is actually not really a BDK specific thing. We're just gonna use normal Rust Bitcoin code, basically.
Cool.
And so I don't know. Do you wanna like open the documentation maybe so I could show you which, I don't know, what are we gonna use, or should I just?
Let's try and go. Let's just try and code away and see how we get on. Like the VS Code is kind of smart enough to like pick up inline documentation and auto import dependencies and stuff, so we might get away with it. So let's see how we go by just going straight in.
Okay. So well, basically you need to create a new secret key structure.
Okay.
Secret key is part of the SecP. Yeah, exactly. You create a new variable you store. It is going to be secret key.
Okay, so and you said it's part of the SecP 256K1 library. So is that
exactly.
like that's a library, right? Okay, so I'm already getting some stuff popping up on.
Yeah, exactly.
Okay, so we want SecP 256K1.
Yeah,
okay,
double colon, then secret key with the S and the key, with the capital S and key, secret key.
Secret key. Whoops. Okay.
And then new. Yeah, this is what I'm suggesting you. And then to this new, you need to give it a RNG object basically. So when you create a new key, you need some randomness for the new key, obviously.
Okay, so this is
and in this
we
case,
generate some randomness here. Okay. Makes sense.
Yeah. So this is rand double colon thread RNG. So it's thread underscore RNG, exactly. And I think you need to give it a mutable reference. So not the whole object. It's like ampersand mute this thing. Okay, so this should generate a new key. But this is like just the secret, the secret thing. We need a private key object because the private key object contains also some other like metadata, like the network on which this key is valid.
Nice. Okay, so we can have another variable.
Create another variable. Yeah, like private key.
Private key. And you said this has some
and this
has various properties, yeah?
Yeah, so the name of the structure is just private key with a P and with a capital P and K. And this comes from Rust Bitcoin, so it's probably gonna, exactly. And I don't know if it added the import for you. I will see later.
So, all right, I know why it's not adding the import. Give me 1 second because I need to build again, I think. So let me try and build again, and it should give me like auto import information. Let's see. So do a cargo build.
Yeah, it's gonna suggest you.
Okay, it's gonna moan at me there binding. Okay, and let's see.
I think actually the error you got there. What version of Rust are you using? Because this is.
Oh, okay.
Can you do like cargo version? I think this is pretty old. Yeah, it's from August 2020. So while we code, you can update it in background because BDK needs, I don't remember which one, I think 151 or something. So this is not like BDK doesn't work with this old cargo version.
Oh, I see. Okay, what's the command to update the Rust version again? It's.
I think if you used Rust up, it's probably like Rust up update. I can look it up right now.
Yeah. I might have to Google that as well, actually.
Yeah, it's just Rust up update.
Okay, it's just Rust up updates. Okay.
Yeah, and it's gonna now. This is a very much newer version from 2022.
Okay.
Yeah, so with this one, it's gonna work. Okay, so once this is done, you can try compiling again. This probably it's gonna start over because every time you change the compiler, it starts recompiling everything from scratch.
Okay.
I don't know. Do you want to keep coding while this goes, or are we gonna wait for it?
Let's keep going. Yeah, let's keep going. Let's keep coding. Okay, so we have this struct private key that has what properties like associated with it?
Yeah, so the first one is compressed, which is whether the key should be represented in the compressed form or not. and we want it to be true, so compressed true, because we actually on Taproot we can only use compressed keys.
Okay.
So we will not be allowed to send a transaction that is using a non-compressed key. Then we have network. And in this case, we want testnet. So it's network, and then there's an enum called network. So it's network :testnet.
It's not like that.
Exactly. And then key.
Testnet. And then key is the last one, yeah.
Yeah, just key, which is the actual like secret thing in there. So we create like a random secret, and then we put this inside this private key object, which has the other like metadata as well. And then you can actually just print this. You can print a private key object. It will print it as a ed with WIF format.
See if it's finished.
So you can just try running this.
Okay, so I think we did update Rust. Let me just check the version again. Oh no, that's the cargo version. The Rust version. Okay, so we're on 1.5.8.581, and then should I build again now at this stage, or?
Yeah, try building again. It should be.
Let's try building again.
In the new one, using a new one.
Yeah.
No, but I don't think it is. I think it's still using the old one.
Yeah, it's still using the old one, right? Let's see.
You could try.
Let me open the terminal and I'll just check here quickly. Cargo. Yeah.
There's a way with Rust up to override the version for a specific repo. So I think you could do Rust up override. Let me check.
Google in here.
Yeah, let's try with Rust up override set. Let's start with this set nightly. So it's gonna switch to nightly compiler, which I know is new. So nightly, like night LI. Yeah, sorry.
Is that right? Yeah. So Rust up override set nightly.
Yeah, and now it's using Rust 1.60 nightly. So this is very recent. And then you can try building again.
Oh, okay.
And it should hopefully be using the new version. Yeah, so this is starting from scratch because it changed the compiler version.
Oh, nice. Okay, cool. All right. How are we getting on in the chat, guys? Any questions so far? We're still like in the early stages, but feel free to answer any questions that you might have as we're going through this. Just rebuilding again here. Okay, while that's building, I guess we want to do a little print line here, don't we? So let's be a bit patient. It shouldn't take long.
Yeah. So my plan was to run this like 2 or 3 times and save like in a text file a few of those keys because we're gonna use them later.
Okay. Nearly there. Okay, this is the errors that I was hoping for. Yeah, cool. So it's complaining that I've not imported those modules, basically. Yeah, that's what I was looking for. Okay, perfect. So while I've got an extension, I think it's Cargo Analyzer, so it should give me some errors actually in the file in a second while it's finished analyzing the file. Let's see if it does it. Yeah, there we go. That's what I was looking for. So VS Code is smart enough to allow me to just do auto imports. So I can fix all of these. I can import this struct from BDK Bitcoin private key, and I can also import this enum from network. Should stop us complaining at us, and then getting this annoying message saying should have a snake case. Oh, okay. So
yeah, because usually in Rust you use snake case, but you're not required. It's just more of a styling thing.
Okay, so the linter's moaning at me a bit there as well. Okay, Does that look all good? Does that look good for us to print this out and see what's happening?
Yeah, should be good.
Yeah.
You can you can try running it and see what. Okay, so this is one key, one private key.
Okay.
I would just like create a new file, like a temporary text file, and we can paste a few of those in there.
Okay.
Yeah, like a keys.
Something like that, yeah, and then just copy that in there.
Yeah.
Cool.
And maybe run it a couple more times so we can have 3 keys in total. I don't know if we're gonna use them, but since we're here, we can just do it.
Okay,
right now.
that sounds good. One, and then we'll get one more.
Perfect. Yeah.
Cool.
Okay.
Awesome.
Yeah. So now we can actually start writing like an actual Bitcoin wallet. You could remove this code, or I don't know if you wanna maybe comment it out or remove it entirely.
Yeah, let's comment it out. So
anymore.
yeah, I mean, we can comment out just to make it clear that we're not using it anymore. Yeah. Okay.
Yeah. So basically now we have to create. Yeah. We have to create like the actual wallet, like the actual BDK wallet. And when you create a wallet, you basically you need like a few pieces that you need to put together. So the first one is the descriptor, which is what I was mentioning before. So it's this basically string of text that describes your wallet, the script that you're gonna end up building with your wallet. So usually, maybe you've seen those already somewhere.
Yeah.
The WPKH. This is the most common like type of wallet. In this case, we're gonna
let's just
write.
Remind the viewers what we're talking about here. So these type of things, right? So these define like different address types as well, right? Public key hash, witness public key hash, yeah.
Yeah, so the first the public key type scripts, they only take a key. So you can write like a PKH, and then between the parentheses you write down a key. And the SH, so like the script types, they take more opcodes inside, which is basically the ones described in the table below. But in this case, we're not gonna be using those. We're just gonna make a simple single sig basically wallet. But in this case, instead of a WPKH, which is a SegWit single sig wallet, we're gonna use a TR, a TR type of wallet, which is a Taproot script.
Okay.
So this is the first thing we're gonna need. Another thing we need is a database. What is called a database is basically like a cache that the wallet uses to store things in there. It doesn't store keys. It's the cool thing about the database is that you can completely delete it, you can lose it, and it doesn't matter. So there are no critical things in there. It's just a cache. It just makes other operations faster. And then we need a database with a blockchain. So these are like the 3 things we're gonna create, and then we can create a wallet with these 3 things. So you can create a variable, like a descriptor variable, where we're gonna write down the descriptor.
Okay.
And this is a string, so you open double quotes. And this is a TR, so like literally TR, open parentheses, and inside you can paste one of the keys we've generated.
Oh, okay. Like that. Okay.
So this is basically what this is saying is I want a Taproot wallet using this key as my main internal key. This Taproot wallet is not going to have the whole like tree of scripts. It's just going to be basically a Taproot single sig, a Schnorr single sig wallet.
Got you. Okay, got you.
Yeah, if you have any questions, feel free to.
Yeah. So from this style of key, we won't be able to like derive a HD wallet from this key. Is that correct?
Exactly.
Yeah. Okay.
Basically, this
Yeah.
descriptor only has one address associated
Okay.
to it. It's one key for one address.
Okay, cool. Yeah, that makes
And
sense.
this is not like a Taproot limitation. It's
Yeah.
just my fork of BDK that supports Taproot. In the real one, we're still gonna support HD wallets, obviously.
Yeah. Okay, that makes sense. Cool.
Okay, then we need to create the cache, so you can create another variable like cache. And in this case, just the quickest thing to do is use the memory database, which is basically a database or a cache that is only stored in memory. So every time when your process terminates, this cache is deleted. But at least it's much easier to prototype with this, because if you store the cache on disk, then you need to load it up next, and it gets a bit more messy. So in this case, we can just create a new temporary cache, and we're just gonna delete everything inside every time. And it's just new, doesn't take anything, just a new, yeah. And then we need a blockchain client. And maybe I should also mention BDK supports many different types of caches and blockchain clients. So in this case, specifically, we're using the memory database, which is this kind of temporary thing, and we're using the Electron client. But you could also use compatible filters as your interaction, as your way to interact with the blockchain. We also support Bitcoin Core RPC. So if you have your own full node, you can connect to it. But in this case, it's just easier to use that.
Okay.
So yeah, so we need to create a client object.
Okay. Client.
So this is like.
Once again. So is it literally like that?
Yeah, just like that. Client new.
Yeah.
And inside we need to provide the endpoint it's gonna connect to, like a URL.
Okay.
Maybe you can copy paste this one from the.
Yeah. So let's see.
Thing.
So this is the one hosted by Blockstream, right? Yeah. Okay.
Yeah, exactly. Oh, and also I forgot now, but we should also we should change the return type of the main function, so that we can use question marks everywhere. So basically, we can change the main function to return a result, and it's gonna make it easier for us to do other stuff.
Okay.
So exactly, the parentheses.
Yeah, go ahead.
The parentheses are fine because this is the return type. And then for the error type, we need, this is a bit more convoluted, but it's box. Oh yeah, it's suggesting it. So that's, yeah, exactly that.
Okay. Where is this error coming from though? Is this just a standard out error, or is this import error?
Yeah, this is from the
because there's quite
standard,
a few. Right?
This is STD.
Yeah, because so you got BDK Bitcoin error, STD here as well.
Yeah, STD error. Okay. Yeah, that one. This is like basically a generic error. And then since we are basically declaring that we return a result, we need to return something at the end of the function. In this case, an OK, because everything went fine.
Okay.
So yeah, just that.
Cool.
And so with this, you can use question marks. So for instance, when you create the client, you can add a question mark at the end, because the client new returns an error. Like if you can't connect to the URL you provided, it returns an error. And we want to use the question mark, so we only take out the OK case, like when it works fine.
When it's successful, yeah. Okay.
Okay, and now we can create the actual wallet. So we can create another variable, like a wallet.
Okay. I think I can copy this one, because we have done this quite a few times in previous streams. So
okay.
let me copy this one over. We've done this quite a few times with Raj and with Thunder Biscuit as well. So I think viewers might be quite familiar with instantiating a wallet, but we can run through it the code line by line anyway. So we'll fix our imports quickly.
Yeah.
And and then we can just change the client.
Yeah, so you should replace, like, instead of hard coding a single descriptor in there, you can replace it with the descriptor variable we created.
Yeah. Okay. Yeah. Okay.
And also the memory database new. I mean, it probably wasn't necessary, but
yeah, it's okay.
Yeah, I did everything in line, but I think this way is a bit clearer for for people to understand.
That makes sense. Okay, cool. So we have this wallet instance now that takes a descriptor, and what's the second parameter we have here? We have a none, but what is that? Let's see. Okay.
The second parameter is basically an optional chain descriptor. So it is basically if you want your wallet to generate change addresses from a different descriptor, you can provide one. If you don't, it's just going to generate change addresses from the same one.
That makes sense.
Yeah.
It's annoying that I can't get the inline description of it. It's fine. I don't know if we've done this quite a few times before. So I was going to say, do we need to go to the docs? But we have done this quite a few times before, and it's quite self-explanatory. So descriptors first parameter, and then a second descriptor for your change addresses, third parameter for the network you want to use, mainnet, testnet, reg test. Does it support signet as well, or?
Yeah.
It does, yeah. Okay, cool. Your cache, and then basically your block source is the final parameter.
Exactly.
Yeah. Okay, cool.
So yeah, now with the wallet we can print out its address. In this case, it's just one, as we said before.
So we can do wallet.
So we can use
dot. Oh, not is it dot? Get
like
address. Or did you say?
I think it's get underscore.
What do we want? Address or?
No, it's get address. Yeah, just the address, because we're gonna send some funds to it, so we need to print out the address. But it's get underscore address.
Got you.
And then the get address method, it takes an extra parameter. So you need parentheses because this is like a function that you call get address.
Got you. Okay.
And you need some parameters in there because you can say I want the 10th address, like for HD wallet. So you need to say which address you want. And in this case, it's just, we can basically say we want a new one, which is going to be the only one. So you need to provide it an address index enum. So it's address index :new.
Address index.
Exactly.
Enum is new.
Because in this case, we want just a new address. You could say I want the 10th address, or
okay.
And you need a question mark at the end because get address is a function that could fail, so it returns a result.
Exactly. Okay, cool.
So if you run this, it should print out the address for this one.
Okay. All right. Nice. And I see we get a TB1. That's not a. Is that a Taproot address? That's not a Taproot address yet, is it?
No, this is
your standard Batch 32 address.
No, it is actually a Taproot address, but the TB is just for testnet.
Yeah.
So the prefix is the network. So this is a testnet. I don't remember exactly. I think the PQ. So what comes after TB1 defines kind of the type. So I think PQ is typical of Taproot, but I don't remember exactly. It's slightly different for the old vector zoo kind of address.
Okay, got you.
So yeah, so we should send some funds to this address. Do you have some testnet, Bitcoin testnet?
No, I don't actually. Should we try and find some? Should we try and find some? Yeah.
You could use a faucet if it works. Otherwise, I also have some, but maybe that's the
Yeah,
quickest.
it might be interesting for the viewers actually. Does anyone have any
Yeah.
test coins they can send me? If not, I'm gonna I'm gonna go to one of the faucets and get some. I'll just type in Bitcoin testnet faucet and see what comes up. All right, there's this Bitcoin testnet faucet at
I usually use the third one.
Third one.
I don't know. I usually use that one because I think it's the best one. It works.
Okay.
It works the best, but
yeah, I'm gonna trust you. I think I've used this one before anyway.
I recommend it.
Yeah. Okay, yet another Bitcoin testnet faucet. So yeah, just for anyone who doesn't know, this is how would you describe like faucets? Is it just like a place where you can get testnet coins and it's like a node hosted by someone in the community and allows you to like play around with Bitcoins that don't have any, I guess, real world value, but allow you to still play around with the functionality in like a test environment?
Yeah, exactly. It's basically like free testnet Bitcoins. You just give it an address and they're gonna send some like little fraction of a Bitcoin to you.
Yeah. So in this case, it's 0.001, and you can't.
Exactly.
You can only request a certain. Oh, I've got. I didn't solve the addition right. Apparently, I can't count. So is that a plus or a times though? It's usually.
I think it's always a plus, but I'm not sure.
Yeah, it's always a plus. Yeah, let's try that again. There we go. Okay, looks like it was successful. Do we want to go back and do we want to check this in like a block explorer or anything, or should we just keep going and just assume that it's all done and it's all good?
Usually it works, but yeah, we could open the block explorer because we are going to open it anyway later, so we can just do it now.
Anyway,
I usually use mempool.space because it also shows very well some Taproot stuff.
Yeah, I'm with you. Okay, let's use mempool.space. And then we need to change.
So, yeah, you have to switch.
Yeah. And then, I copied the transaction ID. Yeah, okay.
Yeah, cool. The transaction is there, and there's also our address there.
Cool. TB1 PQ. Yeah, this is our one here. Okay, awesome.
Yeah, exactly.
Okay. All right, cool. So where do we go from here?
So now we just basically have to spend from this address and send those funds somewhere.
Mm-hmm.
I think maybe the best thing we can do is return those to the faucet, maybe. Unless you have, I don't know, some other.
Yeah, no, that sounds good.
So I think on that page they have an address to return back the funds.
Let's see. No, that's an actual Bitcoin address.
I think at the end. Yeah, that's one. Give back.
Give back. Yeah. Okay. Cool. So let me just paste that here and just comment it out for a second.
Yeah.
Okay, cool.
Okay, so first thing we need to do is sync the wallet. So basically, we tell the wallet to connect to the blockchain and fetch, look for transactions and basically synchronize with the blockchain. So you do this with wallet.sync.
Wallet.sync. Okay.
And there are, I don't know, do you want to copy paste this? Because there are a couple of parameters that you need to give it. Or I could also.
Let me see. What am I looking at here? Wallet.sync. So is this the bit about so you mean for building a transaction or just to sync the wallet?
No, this is just to sync the wallet. It's at line 60 of the gist I sent you.
Okay, so we just basically want this, basically.
There's a wallet.sync.
Yeah. Okay.
Yeah, because there are a couple of parameters. So the first one is a progress object. Basically, it's a way, like if you want to be updated about the progress of the sync, you can give this. You can give sync your own like function that is gonna receive updates. But in this case, we just do a no op because we don't care about the progress.
Okay.
And then the other one, I think it's an optional. You can specify a different number of addresses to generate, but in this case, we don't care because we only have one address, so it doesn't really matter at all. And then once it's synced, so basically sync, as I was mentioning before, it just connects to the blockchain, download transactions for you, and at the end, you are synchronized with the blockchain, and so you can ask the wallet what's the balance, because you. Yeah, so basically synchronized, so you know if you have incoming transactions.
Yeah, one second. So I didn't quite catch that. So the first parameter is, because I'm just reading the inline docs here, it says database. So we used an what is it? Our cache is just using a standard memory database.
I think this is the new. Yeah, the problem is this fork is based on an older version of BDK. So in the new version of BDK, yes, you give it a database. But I think this is based on 0.13, and now we are at 0.16. So yeah, it's a bit old. It's not super. Yeah, so it's a bit different. But yeah, in the new one, you give it a database. It's a bit different.
That makes sense. Okay, cool. And then yeah, we just print up balance.
Okay.
So, okay, cool.
Exactly.
Just one question.
You could try running it.
Yeah, before we run it, one question from the viewers. Can you mine testnet coin?
Yes. Yeah, you can. It's basically like mining real Bitcoin. It's just that you don't get your money back on electricity. So very few people do.
Yeah. Okay. All right. Let's run this and see if we can see what the balance is here.
Yeah. So,
okay. Cool.
Yeah, this is right. It's represented in Satoshi, so this should be. It's non-zero, so that's good.
Yeah. Okay. So what's that? 100,000 Satoshis. Okay. Cool. Yeah. So that the faucet sending us some testnet coins worked. That's good.
Yeah.
Okay.
And now we need to send them back, just to show a transaction. So again, I think it's better if you copy paste this because it's a mess to spell, and then I'm gonna explain what it's doing.
Okay.
So basically, this is creating a new builder object. So this is like kind of an interactive process where you tell the wallet, I want to create a transaction, and you get back this builder thing, and then on this builder, you can call methods to configure the way you want to build the transaction. So in this case, what you would do usually is like add recipient. So you could say, add this recipient. I want to send 1 Bitcoin to this address and 2 Bitcoin to this other address. In this case, we don't have. We don't want to send a specific amount. We just want to completely empty the wallet. So we use the drain wallet function, which means I want to spend everything in here. I don't want to send 1 Bitcoin or 2 or 3. Everything you can find inside.
Interesting.
And then we use the drain to basically tell the wallet who's going to be the recipient. We're going to send everything to this address. And in the code you copied, ret addr was a variable containing the return address.
So this is this one up here.
So yeah, we can create it right now.
It still needs to be a string, yeah.
This is not just a string. You need to parse it as a Bitcoin address. So you create a new address object. It's address from str.
Yeah, got you. So address from
from underscore str.
Address from
Exactly.
string. Okay, cool.
Yeah, exactly.
Whoops, I've deleted something here. There we go. Typing too fast. And then actually need to give it a string, and then I need to import the address struct.
Yeah.
So
It's the first one.
The first one. Okay.
The other one is a network address, like if you connect to a peer, but it's not what you want now.
And this is moaning at me. Why is this moaning at me?
Yeah, you need to import the from
okay.
string.
From
thing.
string.
And also you need a question mark at the end, because this also returns a result, because it could fail. Like if you provide an invalid address, it would fail. Also, the last thing we are giving the builder is the fee rate. If you don't give it any fee rate, it will just use the default mean relay fee rate, which is 1 Satoshi per byte. The problem is there is a bug somewhere in the Taproot code in this prototype I made, which sometimes underestimates fees. So you end up creating a transaction that is valid, but you can't broadcast it because the fees are too low. So I just set it to 2 Satoshi per byte just in case. So yeah, basically what we are saying is we want to create a transaction that drains the entire wallet. We drain the wallet to this address, and we want to use a fee rate of 2 Satoshis per byte. And then when you do the finish, it will like actually create the transaction, and you get back a PSBT and a details object.
Cool. And in BDK, everything. Sorry, just a quick. In BDK, all transactions are PSBTs by default. Is that right?
Yeah, basically you use PSBTs a lot to like interact with the wallet. So yeah, you get the wallet creates the PSBTs, and then when you sign, you give the wallet a PSBT to sign, and yeah.
Okay, cool.
So yeah, the details object, we can kind of ignore it. It's just like a recap of the transaction. It's gonna tell us I'm spending X Bitcoins and I'm receiving 0 in this transaction and stuff like that. We need to sign the PSBT now, because now we've created the PSBT, but it's not signed. It's just like a skeleton of a transaction in a way.
Yeah. Okay.
So for instance, you could have like a watch-only wallet that doesn't have private keys. You could create the transaction there, move it like to another safe wallet that has the keys, and sign it there. In this case, we have the keys already here, so we can just do everything in one place.
Okay, and this is this is basically the final step in the penultimate step in the transaction flow usually. So we're going to sign, and then I guess the last step is to actually now have this signed PSBT, and you want to broadcast it to the network you've specified when you created the wallet.
Yeah, exactly. I mean, at least for like simple wallets, this is the flow. For more complex, where we have like multiple people interacting, there's somebody creating the transaction, and then you give the PSBT to somebody else, and they sign it, and you give somebody else again. And then at the end, once you've collected all the signatures, you can finalize the transaction and then broadcast it. But in this case, again, it's very simple wallet, so it's just all in one place.
We'll have something called like finalize, which takes does it take our PSBT? This point?
So finalize is what you get back when you sign. So when you sign, you get back a result that tells you if the transaction was finalized or not.
So our wallet,
and this is because again, sorry, go ahead.
No, I was just saying. So our wallet has the ability to like sign function on it that allows us to sign.
Yeah, because in this case, we provided the private key in the descriptor. We could also create like an equivalent descriptor that doesn't have the private key. In this case, you would be able to see the transaction coming in, you would see the balance, but you would not be able to sign because you don't know the secret, the private key. So what I was mentioning before, like if you have like a large multi-sig, it could be the case that you sign, but the transaction is not finalized, meaning that you need more signatures, basically. So this finalized is like a result you get back that is going to tell you, okay, the transaction is ready to be broadcasted, or if it's false, it means that somebody else needs to sign the transaction.
Okay, and what does it look like when
so yeah,
that
this
happens?
takes,
Does it give you? It just gives you. Is it specific in like the error it gives you, saying like, oh, needs to be signed by n number of, it needs n more signatures for the transaction to be valid?
kinda. So basically, when you sign, you just get back a true or false. It's
Okay.
true, it's finalized or not. But there are some other like tools within BDK that you can use to get this information. So there is basically a part of BDK that analyzes transactions, and you can look at the transaction and it can tell you this guys have already signed, but we are missing this other person. But this is an extra like analysis thing that you can run if you want.
Okay. All right. Awesome. Okay. So this wallet.sign, I'm getting an error saying this function takes 2 arguments, but 0 was supplied. What are the 2 arguments?
So the first one is the transaction you want to sign. So it's your PSBT, basically. And in this case, a mutable reference to your PSBT, because you are mutating the PSBT. You are putting signatures inside.
Yeah. Okay.
And the second argument is just some options that you can use to tweak the signing process, but you can use the default ones. So you can do default, double column default, and it's just going to use the default options, which are fine for what we're doing now.
Okay. Cool.
I think, again, you need the question mark at the end before the semicolon.
Here?
Yeah.
Okay.
And if you want, we can try running this. You can print finalize, and we can try running it, and it should say true, because in this case, you only need one signature, and we are providing it. So it should be able to finalize the transaction.
Run. While that's running, just making sure all caught up with the comments and stuff. Oh, nice comment there. Excellent knowledge dropping. Thanks again. Appreciate it, Eski. Thanks a lot for that. Okay, so yeah, okay, we got true, meaning we had the needed signature to sign for this transaction.
Yeah. So basically now you have a valid Bitcoin transaction. You just need to send it, broadcast it to the blockchain.
Okay.
Actually, there's a step you do before. So now you have a PSBT, but you need a raw transaction. So you need to extract the transaction. So the first thing you do is you can store this in a variable like let transaction equal PSBT dot extract tx.
PSBT dot. What did you say? The last bit, extract.
It's extract underscore tx, because the PSBT is basically like a wrapper over a transaction with some extra metadata and other stuff inside. But now we need the actual transaction to broadcast.
Got you.
And then I think it should be just wallet dot broadcast transaction.
Broadcast.
Oh, it's actually a reference to a transaction, so you need ampersand transaction. And the question mark at the end, because again, this is a result and cool.
Okay, cool. Just wanted to say as well, like it's just before we do this last little bit, I mean, it's very similar to like what we've done in the past streams. Like the only difference I'm seeing is like this, basically the descriptor we're providing, and obviously in this case it's very simple, like because it's just a signal signature, but it seems like this certainly highlights the power using descriptors, right? That like you can essentially like instantiate the wallet for the most part in any type of wallet in the same way, but the flexibility comes around using your descriptors in different ways. Would you say that's fair? Or
Yeah, that's exactly basically the goal of BDK. Like you write your code once, and then you can just tweak the descriptor, and you can change the behavior of your wallet. You have a lot of flexibility. Like traditionally, if you wrote a single sig wallet and then you wanted to, let's say, add multi-sig support, it would be a mess. Like you would have to change a lot of parts of your code because they would all be designed just for a single sig wallet, basically. And instead, with descriptors and with BDK, but also with other, like with Bitcoin Core that also supports descriptors, you have a lot of flexibility. You just change this like configuration string, and everything works without really touching anything else.
Yeah, it's kind of crazy. That's super impressive, man. Like this like mad protocol update that we've had, and then like as an application developer, you just like write one line and you get access to it. It's kind of mad, but that's the good work you guys have been doing, I guess.
Like we do the we do the hard work to support like these new upgrades, and then as a developer that uses BDK, you just have to change like very few things.
Yeah, awesome. Okay, cool. And then
so you should try
is to broadcast this. Yeah,
just try running this. It should create and send the transaction.
If we want to be able to check that we've sent it, though, we're gonna want some transaction ID that we can check in maybe a block explorer again, similar to when we. Is that possible?
Yeah. So wallet broadcast returns the transaction ID.
Okay. So it does. Okay. So
you can just
we can do something like this.
And you can print it out.
Yeah. Okay. Timing's perfect on this, so let's run this.
Yeah.
And then see if we can get a transaction ID back. Cool. So we get a transaction ID back. We've sent it back to the testnet faucet that we originally got testnet coins from, and I guess we can check in our block explorer if that is true or not. Pasting that in there, and yeah, that looks right because that's the address. Yeah, exactly. I can. Oh yeah, and we can see features.
Yeah, it says Taproot.
Yeah. Awesome.
Yeah.
Wow. And then that's the address that we sent it back to. Cool, man. Cool. Yeah. So that was pretty straightforward. Like to just add like this new piece of functionality with all the benefits that we described earlier. We've got 5 minutes to go, so we did talk a little bit about maybe trying to extend this into something a bit more complex. What would something slightly more like complex look like for using Taproot? Like I know we mentioned multi-signature setups that require multiple signatures. Like, is that something you'd suggest some of the viewers maybe go away and have a little go at?
So this is basically 95% of the code is just this. It remains the same. If you want to play around with it, you mainly just change the descriptor. I don't know if you want to, maybe you could show on screen the original gist I sent you, because that was a bit more of a complicated example. But just to show that it's basically the same.
Let me zoom in a little bit here. This is the right one? Is this
do you have the other one? But,
let me see. Yeah, I can get that one.
This is also good, but the other one was a bit more, advanced.
Let me see. You might actually have to send it to me again in our chat. Let me see, because
Okay.
let me see. I don't want to. Okay,
Okay,
actually,
so I need it now.
okay, you've got it. Okay, let me get this up.
So this
Okay,
was
here we
like
go.
the actual code that I used to make a mainnet Taproot transaction. There was also some other code in there because it was like a bot. It was basically programmed to, as soon as Taproot activates, immediately send the transaction. So there was a bit of other code around this.
Okay.
But basically, if you look at it, the main structure is very, very similar. The main difference is the descriptor, which in this case, it was an unspendable key, basically a key that you can prove you can't spend from. It's at line 50, I think. Line 50, yeah. That's the descriptor.
Okay.
So this was the descriptor. And it was, instead of being a string, this was represented with a macro, but it's just like a technical difference, but it's essentially the same thing. And in this case, instead of a simple TR key, this was a TR with an unspendable key, and then a multi-A, which is a multi-sig. In this case, it was a 1 of 2. So your threshold is 1, and you have 2 keys. So this was like a Taproot address that contains, you can't spend like with a single signature. You have to fall back to the scripts. And in this case, the only script inside was a 1 of 2 multi-sig. So this was a bit more like complicated, but in the end, it was like essentially the same thing.
Yeah.
I don't know if I could try sending you the actual like mainnet transaction that I created with this.
Yeah, sure. Oh.
So okay, so I think it should be here.
And our transactions got one confirmation. I didn't realize that when you get a confirmation, mempo.space does this little jingle in the background, music jingle. That's
yeah, yeah. They have like
realized.
a lot of those.
That's cool.
Yeah, like hidden Easter eggs and then whatnot.
Yeah. Nice.
So it's not working for some reason, mempo.space, but yeah, I mean it's not the end of the world. Just
okay. Yeah. All right. No worries. We can maybe post
okay.
it later or something. But yeah, okay, so
yeah, don't know why it doesn't work, but yeah, it's not important.
Yeah, okay, no worries. So yeah, I mean the time is perfect. We've just got on the hour mark here, so we're about to close out. But let's answer any like questions that people might have for maybe a couple of minutes, and then we'll sign out. One from Michael Folkson. Hello, my friend. What work still needs to be done to get BDK fully supporting Taproot? It isn't just merging in Alekos branch, I'm assuming.
Well, no, not just merging. There is a little bit of cleanup needed because I was basically using a very cutting edge version of Rust Bitcoin, and some Taproot stuff in Rust Bitcoin itself were not completely ready. So there were, after that, I opened a few PR myself, and also other people contributed a lot of new Taproot code to Rust Bitcoin. So it's mostly a matter of updating my fork, my branch to use the new Rust Bitcoin stuff. Also add support for a few things that are missing, like HD Wallet, for instance.
Is there an issue open? I think I remember seeing
I
one.
don't think so. So there is.
Is this something people should follow? This issue here, or not really? This is not too associated. So
well, yeah, this is I think this is the right one, but we just didn't really update it a lot.
Okay.
I was mostly talking about the development on Discord.
Okay.
So on Discord we have a dedicated like Taproot channel. So a lot of basically when I was working on that, I was posting a lot there. So yeah, basically it's not just merging. There is a little bit of cleanup, updating. Also, this was, as I said, based on an old version of BDK, so I need to sync back with the other upgrades that happened on BDK. But it should not be like a major work.
Okay, very cool. All right, I'm gonna stop sharing my screen now and go back to this view. Is there any other questions from you guys? I hope you guys enjoyed that one. That was another like awesome workshop highlighting just how easy it is to build wallets and with a large degree of flexibility in very minimal amounts of code. Like if anyone was at the Thunder Biscuit one they did before, like your first wallet with BDK on Android, yeah, that was pretty similar to this, like very minimal amount of code to be able to send, receive transactions. And yeah, like the stuff we preach about it being us, the library handling a lot of the low level stuff is very true when you come to actually coding this stuff. So awesome work from you guys, definitely. Dopeness every time, appreciate it. So yeah, Alekos, any last words before we sign off? Like, is there what do you encourage people to do? Like, come and contribute to BDK if they're interested, or just like dive in and start to use the library if they're interested in building wallets and other types of apps? Where do you recommend people go from here?
Yeah, well, I mean, sure, contribute, please come contributing to BDK. Also join our Discord server. It's linked everywhere. We don't need to show it. You can very easily find it online. A lot of the discussion is happening there. And if you are, I don't know, building a Bitcoin product, consider using BDK. Contact us if you need help. We will try to do our best, to help everybody.
Awesome. So all right, thank you guys for that one. That's another show from us. We'll see you again next week. And Alekos, thanks again for your time. Signing out. Peace.